Welcome back to the Cloudcast. I'm your host, Brian Gracely, and today we have the great fortune of not only getting a chance to talk about some things that we've talked about for a long time on this show, but get a chance to talk to somebody who was really the creator of just an incredible movement, an incredible set of technologies that have been the foundation of really 10 plus years of things that are being built, that are being created, are still being created. So we are super, super excited to have the opportunity to speak with Solomon Hykes, who is founder and co-founder of Dagger, also co-founder of Dagger, as many of you know. Solomon, welcome to the show.
Thank you. Thanks for having me.
We were scheduled to record this a little while ago. We had some travel challenges. You were going and doing keynote at KubeCon in Paris.
Right.
We had some technical difficulties, but it's great that we finally get a chance to do this. I'm sort of tempted to start with a little bit of just putting the last 10 years into context. But let's do this. Give folks right now kind of a sense of what you're working on now, and then I want to get into the thing that we were talking about before, which was really how the things that you're building at Dagger, some of the core people that you're still working with, have been building on this vision that you started at Dagger that you've been able to build upon. But let's start with Dagger. What it is for folks who may not know about it, and really just kind of the scope of the challenge that you've been trying to solve for the last couple of years.
Sure. Yeah. The two are related, as you know. So my current startup, Dagger, is it's a tool that helps you simplify your DevOps pipelines. Mm-hmm. All the automation that is involved in shipping an application, taking it live. So that's build, test, deployment, and then just a lot of tasks to automate. You can think of it as like the factory that mass produces your application.
Right.
Once your hands are lifted from the keyboard, the code's written. Now, the delivery begins.
Yep.
And so automating that is always a pain, always has been a pain. It's just rife with scripts and 50 tools glued together, sort of like a messy workshop,
Yeah.
And that's just because of growth and the fast pace of software. You start out, it's an idea, you and your buddy, you're coding, and then before you know it, things are growing, and there's never time to go back and clean up the workshop. You're just sort of always late, always running, and the team's growing, and they bring their tools, so the mess just kind of grows and grows until eventually that complexity kind of catches up with you, and it becomes a problem to be dealt with,
Right. Yeah.
And so Dagger is a tool that you can that helps you deal with that complexity and really radically simplify the pipelines.
Yeah. No, I think those two images or two analogies are really good, because on one hand, if you've ever toured a very highly efficient factory, it is clean, it is fast moving these days, it is the processes are very, very well defined. And if you kind of contrast that with a workbench, I think about like what's in my garage. There are plenty of tools that are very specific, right? I'll have a chisel for certain things, but I've also got a bunch of big hammers and little hammers. And I think for a lot of companies and development teams and so forth, like those hammers are around because you can smash things with them, but they're not always the best thing to do. But you don't get rid of them, and so I think the comparison of those two things is really, really good. I've been around this space. You've obviously been around this space for a while. I think the thing that I find the most is people fell in love with containers. They fell in love with the idea of developers having more control, consistency from their laptop through what they wanted to do into production. And I find that over and over again, the place where people get stuck is CI or CI and CD. I'm curious, like, why haven't we been able to sort of fix that along the way? Is it, I'm curious what you've seen. It's just one of those, like, we've had things, we don't want to replace them, and so we get these kind of clunky things in between, or is there something else that you guys have really found that you think is sort of going to unlock this for people?
Yeah, I think it's a gradual process that starts with the adoption of containers. I guess the mass adoption of containers 10 years ago. You know, we were in the middle of that, but you know, it wasn't just us; it was a whole industry.
Right.
We discovered, oh, there's a better way to package up our application and run it in a way that's independent from the environment it's running in, right? So then we can standardize, we can solve problems like, well, it works on my machine, why doesn't it work on this other machine, you know? Right. So they just unlocked a lot of efficiency. And so now a lot of applications are containerized, and so they benefit from these efficiencies. But one step removed from the application itself, you've got this factory that's shipping the application. You know, the CI pipeline, the CD pipeline, the build, all those tools mashed together. And I think the way adoption of containers happened is mostly everyone kept their existing tools and then just sort of applied them to building and containerizing applications, right? So the architecture of the application changed, but the architecture of the factory, of the pipelines shipping the application didn't. Right. You know, and then we started entering a phase where the potential of containers started creeping into the factory. You know, so now it's becoming more commonplace to say, wait, well, can't I containerize the factory itself? You know, can I run my CI pipelines in containers? And all these pipelines together, if you look at it as a factory, that is a pretty complex application itself, right? It's like the application that ships the application. Can't I containerize that? And I think we're just in the middle, at the beginning of that process. Yeah. You know, and honestly, right now it's not looking great. You know, it's just not. The pipelines that ship the application do not today benefit from being containerized themselves. It's just kind of difficult. So we have the current mess. But I think Dagger and other tools, but you know, obviously we think we're part of that. We're at the forefront of revisiting the whole factory with containers as the starting point. You know, like a lot of CI processes still today, they'll use software like Jenkins, which predates containers by a pretty wide, pretty large margin.
A decade almost, right?
Yeah, and then you can retrofit containers into it, but it's not the same. And then you have this sort of more recent wave of CI products. You know, you got GitLab CI, Circle CI, GitHub Actions that use containers, but it's basically Jenkins transposed to use containers. It's not a full redesign of the factory. It's sort of retrofitting containers in. And so with Dagger, we're trying to take it further and say, what if we just started from scratch, redesigned everything with containers as a given? And it turns out, taking it, starting from first principles, you can actually achieve enormous efficiency gains. And we're talking about 10x simplification or more across the board, because there's just layers and layers and layers of band-aids. 20 years worth of band-aids. And if you go back and rethink the factory in a streamlined way, then you get a lot of efficiency. Yeah.
I'm curious, when containers first came out, if we sort of set aside some of the technical details, layered file systems and things like that, the core concepts that people really grasped were this idea that, I was going to have this standard common packaging all over the place. So that was good. I didn't have to worry about formats and that. And then the idea that you could package your dependencies such that as there was a life cycle to the application, it would be consistent. And then at the point where you had to make any changes, you were just simply changing, essentially a layer, or you took out a piece, you put a piece in. And I think people grasped that before they, started getting into the nuances and all sorts of stuff. What's the equivalent, as you're talking about what Dagger does in the CI and CD space? What are the kind of high level things that people, once they grasp it, go, oh, okay, that's the thing that's going to, kind of get us out of this band-aids and so forth.
Yeah. Well, I think that the aha moment, I guess.
Mm-hmm.
Well, first of all, it always comes from a specific set of people within an organization, and that's what we call the designated DevOps people.
Okay.
The people that today are in charge of running the workshop, and they're trying their best to modernize it to become a nice streamlined factory, but they're always struggling to do that because they're always overwhelmed with short-term requests to just fix a quick thing in the workshop.
Right.
And if they could just allocate some time to just re-engineer the workshop into a scalable factory, then everything would be easier. They would not be as overwhelmed, but they never find the time to do that. And so they're sort of in the trenches, and they have a very built-in understanding of the pain. And so they will recognize the correct design way before everyone else because they just recognize a path to solving the pain, if that makes sense.
Yeah, absolutely.
And so, the first thing is fragmentation is just off the chart in these pipelines. It's literally dozens and dozens and dozens of tools that each perform a specialized task.
Yep.
They'll produce an artifact, they'll combine artifacts, they'll run tests, they'll, upload things, download things, generate configuration files. It's complicated.
Yep.
And they don't know how to talk to each other. There's no standard for composing them. Or rather, there is a de facto standard, and that's Bash.
Right.
Sure. Just shell scripts all the way down. And shell scripts are very old, and they're just a very old platform. Right. So they just have a lot of gaps, and so usually the gaps are filled with proprietary CI systems. And so you have this sort of Frankenstein situation where you have a lot of shell scripts all over the place.
Right.
Gluing things together in a very brittle way so that these scripts break all the time. Someone leaves the team and, nobody knows how it works anymore. You can't test them. And then you have these, the other half is this centralized CI system with usually a very proprietary configuration format. Maybe it's Jenkins, maybe it's YAML configurations, GitHub Actions, Circle CI, etc. And then those kind of are connected in this unique snowflake way. And changes are terrible. And the first manifestation of that pain is what we call push and pray.
Right.
So push and pray is when you want to make any change to any of the pipeline, right? And you actually can't run it locally to verify if it works. So it really is software. It's this complicated, automated machinery, right? It is code, but it is code that you can't actually run end to end on your machine. You have to craft a change, check it into source control, Git, push that to the Git server, wait for a complicated machinery of events to fire so that somewhere in this centralized system, jobs are going to be run mysteriously, and then you're going to get an email saying, "Oh, you forgot a comma."
Right.
Well, so it's just this antiquated experience that just slows you down.
Yeah. Well, it's a weird. Calling it a snowflake is sort of perfect because it is this weird thing where it's production software. Because if it doesn't work, you don't get into production.
Yeah.
People may not necessarily think of it as production software because of where it is in the life cycle, but at the same time, unlike a lot of production software, like it's not. You can't sort of stamp them out. You can't build a backup for it necessarily. I don't want to say a backup, but like a mirrored system because of, like you said, the sort of the uniqueness. Like if 3 or 4 teams are working on it, the system might look reddish, and if 3 or 4 other teams, it might look bluish or something. So that variability is super challenging.
And it's exactly the situation everyone was in 10 plus years ago before containerizing the apps. That's what the app server was like. That your production your application running in production was a unique snowflake, and it was how it worked exactly and how to change its, how to update the front end, how to update the back end, how to hook it up to the database, whatever. That was all unique and special and very dangerous to touch and very hard to replicate or stage or anything like that, right? And turning that into standardized, isolated components that you could replicate here, there, and you sort of had control over the inputs and the outputs. Okay, if I run it here and I give it this input, then this is going to happen. That allowed software teams to break down this problem and build confidence. Okay, this container works here, so I have a controlled area where it's probably going to do the same thing over there, right?
Yeah.
And so basically, we just need the same thing for the pipelines.
Yeah. It feels like where you're sort of going is if you could give some of the control back to the application teams as opposed to this centralized team, which is having to deal with a million different requests. Right. And if they could essentially hand off the software plus the pipelines into some pluggable modular thing, it does feel like you could at least have a level of confidence that like this thing ran on my laptop or on my test servers, but the build process is going to then run as well. Like you've moved the consistency downstream.
Exactly.
Walk us through then, kind of with that idea in mind, walk us through what Dagger looks like. What are the components? What are the areas that people would interact with? Yeah.
So I mean, our approach is to take this general idea that the entirety of the pipeline should be like an application that you can actually containerize.
Yep.
So that, like you said, developers can take responsibility for producing one piece of it and they can use it locally. And then, the centralized platform team can take it and run it with the other pieces. And it just sort of, you have this kind of feeling that you're playing Lego with the rest of the team, right? And so in practice, the reason that hasn't happened, other than it just takes time for the full potential of containers to kind of percolate through.
Right.
I think it's just that you need to design exactly like Lego, meaning you need to focus on the individual brick and you need to scale it down in a really good way so that then people can build up from there, right? And it's actually really hard to design something very small and composable that then you can scale out. The first instinct is usually it's easier to make a big complicated machine, and then the problem is to adopt that big complicated machine that will solve all your problems. First, you got to throw everything out because it doesn't fit, right? You got to start over. And that's really not an option in this problem because the workshop may be messy. You may not like it, but it's working. And you can't shut it down and start over, right? Because you got a business to run, you got a product to ship. So it has to you need to be able to gradually fit it into what you have, right? And so so that's our take on the problem, and that take is reflected in the design of Dagger. It's a tool. Mm-hmm. It's a tool that you can just install. It's an open source tool. You install it on your local machine. You install it on your servers, on your CI environment, wherever you need to run pieces of the pipeline. And by the way, much like Docker, I mean, a lot of it is just taking what we learned from Docker and doing it better.
Sure.
In fact, Dagger really is a container engine. So in a way, it is a replacement of the Docker engine, but not for running your application, for running this very specialized kind of application that is your pipeline. And so that's kind of the key.
Right.
It integrates great with Docker. I mean, there's Docker all over the place in modern pipelines anyway. You have Docker files, you have Docker Compose files, you deploy to Kubernetes. So of course you need to be compatible with all of that. But it's a tool. You install it on your machine, and then it's going to run containers for you. But the big difference is that the way you tell this tool, Dagger, to run containers is by programming it. So it's a programmable container engine, meaning you actually write code, little snippets of code, we call them functions, that describe what you want the pipeline to do. But you describe it in terms of these basic primitives that involve containers, like download this container image, execute this command, copy this directory, this artifact from this container to this other container, expose this port, and you do it all in code
Yep.
using calling the Dagger API. And it turns out from that primitive, you can build up everything else. We come in saying the best way to express your pipeline is as a series of discrete tasks, each running in their specialized container, and then with the inputs and outputs connecting these containers clearly mapped out in an API, written in with regular code. So then you start seeing the structure of your pipeline in a very clean model, expressed in regular code that the development team can look at and say, I understand. This function takes this argument and then it returns this. And so you're taking these complicated, usually obscure, arcane concepts that are locked away in a Jenkins file and GitHub Actions, YAML, and weird shell scripts in 1,000 places. And instead you show the dev team a 20-line Python function or Go function, because this is multi-language.
Okay.
And you say, this is your build. The source code is this argument. It's of type directory. And the container is the return value. It's of type container. So we give you these basic types. And all of a sudden, you can express these really powerful workflows in just a little bit of code.
Yeah. So when that happens, when the the DevOps engineer goes, downloads it, starts building some of these snippets of code for the team, what's sort of the end action at that point, right? So hands it off to the development team. They're able to kind of run their own CI, if you will. Is the typical end result or last stage of that something that the previous CI team would look at and go, yeah, I'm good with this. Like I kind of see what you did. I see that you passed your tests, or like what's kind of the normal interaction that you're seeing emerge these days when you start to distribute where CI goes?
So typically it starts with the CI team, actually. So they're the ones sort of stuck with dealing with this, and developers are detached from it. The developers would enjoy, they would benefit from having more control over how their CI works and participating in how it works. But they don't wake up in the morning thinking, oh, I wish I could participate more in the CI process, right?
Yeah.
Sometimes I'll say, well, I wish the DevOps team would hurry up and add my favorite tool to the CI pipeline like I asked them, so that I can take my thing that already works locally in production. But most of the time they're happy, they're productive. Most of the pain is concentrated on the DevOps team who own the CI, right? Yep. I mean, the name of the team sometimes changes,
sure,
but
sure.
Because they're the bottleneck, right? They have to keep it running. And anytime there's any change in any tool chain anywhere in the organization, they have to incorporate that change in the tool chain in the pipeline. So if there's an AI feature now, so the data team is now doing, a whole new MLOps workflow, and some of that needs to go into the product. That's a whole new set of tools that the DevOps team has to figure out roughly how it works. They have to decide which version, how to incorporate it into the CI platform, how the scripts written by that team work, and it's all gibberish. Like, oh, these are all tools I've never heard of, right? And then you multiply that by every team. So usually what happens is there's one piece of that whole mess that is just too much. It's just too painful, and it just passes the threshold where something's got to be done. And that's where a DevOps engineer wanders in our Discord server, which is where the beating heart of our community, and says, I've seen Dagger. Can you help me out? I have a POC. What do you think of this? And then, then it's like a support group. Everyone, all the suffering DevOps people kind of help each other out, and then they simplify the painful part, and then you have this really nice moment where you get a commit with a lot of red. You just remove a lot of terrible scripts and a lot of YAML, and then you just address that problem, and then you spread it from there. Oh, I could Daggerize this other part of the pipeline, and so over time the CI configuration kind of shrinks, the messy scripts kind of shrink, and you have a convergence of the developer toolchain, the CI configuration, and then as a side effect, the DevOps people can now pull in the developers and get them gradually more involved, and say, hey, this is your build. It's written in your language. Anything you want to change? Oh yeah, actually, I prefer this version of that. Great. Go change the code for this build. It's yours now. So it's kind of decentralizing the painful part of the work.
Yeah. Well, and I can imagine. I mean, we mentioned at the top of the show sort of this idea that people have, if you've been inside of a factory, you sort of see how they operate. I mean, the reality is, modern factories are lots of little components, right? They've decentralized themselves. They eventually coordinate how to get a car out the other side of the building, or a widget or whatever it is. So the concept is, and you're essentially, it feels like you're doing a couple of things. Number one, if you've listened to Gene Kim, or you've heard the Toyota manufacturing story, right? You're giving people the end-on cord, around their own application, right? You're not handing it off and making people wait for it to go through. I have to imagine, as this becomes more deployed, the overall cost of CI has got to come down some, because you're not waiting as long as you were before. Plus, you're also, when there's problems, when there's errors and so forth, you're seeing them more quickly. You're not having to wait in a queue. You're not having to do things. So yeah, I can imagine. I mean, because all the environments I've been around, at some point you get to the end of the month and somebody goes, God, my CI bill is killing me. Like it's huge.
Yeah.
And this is one of those areas that you don't necessarily think about as being a massive cost, but if you're running things on a pretty iterative basis, it would be.
And there's the visible costs, and then there's the hidden costs.
Sure.
The CI bill, we definitely see that a lot. Teams saying, "Wow, how did it come to this?"
Right.
But also, every time a developer is stuck waiting, that costs money too.
Right. Yeah. Opportunity costs and so forth. I want to shift gears a little bit in the same kind of vein and same domain. We're seeing tons and tons of new and interesting tools, with some sort of AI built in to help developers, write code, right? What are you seeing? Because if it's able to write code, it's also able now to look at people's code, help debug things and so forth. Where are you starting to see some of these interesting AI tools fit into your kind of ecosystem, where they can, help accelerate stuff or improve quality or things along those lines?
Yeah. Well, for us, taking advantage of AI coding assistance is part of a much bigger objective, which is taking advantage of mainstream development ecosystems, of which these code assistants are the latest part. But from the point of view of the DevOps community, all of it's out of reach, because we're all stuck in this terrible ecosystem of bash scripts and YAML. And so there's an enormous amount of efficiency that you can unlock if you can take this DevOps community that is incredibly fragmented across all these little pockets of proprietary configuration files and shell scripts, and they're not connected at all as an ecosystem.
Yep.
And if you can roll all of that up into a regular software ecosystem that where all these bits of knowledge, of this DevOps knowledge, are encoded in Go and TypeScript and Python, in languages that have proper tooling, a proper ecosystem, and they all interoperate through a common API, which is the Dagger API. Then all of a sudden, as a DevOps practitioner, you get incredible benefits. I mean, you're just so much more productive because, for example, you get auto-completion in an IDE. So when you're developing a Dagger function, you're literally typing what you want to do, and the IDE will say, "Oh, I know what you're trying to do. You're trying to run this command in this container?" Because it knows the types, it knows the IDE just sees regular Go code or Python code.
Right.
And so test frameworks, I mean, even the collaboration workflows, so AI copilots are like the cherry on top, it's just, we're just so behind, even in terms of scale. I mean, if you look at DevOps communities, the average DevOps community is just way smaller than the average app development community. If you look at the number of, providers in Terraform, or I'm just picking that as one example of a DevOps ecosystem, and you compare it to the number of NPM packages, right? It's several orders of magnitude. So just rolling up the ecosystem, making it larger, and not being stuck in our little island. Is the key.
No, that's cool. That's cool because right. It is sort of a little niche, and the more it stays a little niche, the more it's going to be, kind of that idea of like there's only a few people that know this stuff. The more it can kind of spread out to being, kind of an adjacent thing to the software team, an adjacent thing to the DevOps team, an adjacent thing to the security team. Now you've got more people that have a stake in making it easier to use. Codified AI can help with it. You get version control. You get all this sort of stuff that you get in communities like Ansible and Terraform and all these other ones that have Docker and others that have grown so much. So very, very cool. Last question. I'll let you go because we could dive into this a ton. What's if somebody's listening to this and they go, I have those pain points. I'd like to start figuring out if my life can be a little less painful. Like what's the starting point with Dagger? What's the best way to sort of, get up to speed quickly? What's a good experience for them to dive into?
There's really two things you can do and maybe do both. One is just go try the quick start. We have a little getting started section in the docs just to give you a feel for what it is and how to use it. And then joining our Discord server is always a good idea, even if you're not maybe ready to start using it. You're not sure about the right use case, but you definitely the problems resonate with you, and you're just interested in talking to other people that have this problem about how they solved it. I mean, that's basically the Dagger community. I mentioned it's like a support group for DevOps people who are in pain and don't want to be in pain anymore. That's really it. And we're 100% community led. Again, took all the lessons from Docker and trying to do it even better the second time. So, we developed the product in the open. We actually use that Discord server as our office. We're a distributed team, but we're a distributed team without a separate private server. We're actually in there all the time. It's our office. So it's like showing up at our office and saying hi, so it's a really nice vibe. And it allows us to move super fast because we're getting feedback all the time. And so the product itself is rapidly evolving, and it's just a lot of fun.
Yeah, no, that's awesome. That's awesome. It's good. It's good to have you back, very visible in the community. It's good to see that a lot of the lessons from the things that you built before, the things that you learned are reusable, and hopefully this is the same way that Docker kind of revolutionized how development can happen and rapid iteration can happen. This can knock down that next bottleneck. So thank you so much for the time today. We really, really appreciate it. With that, folks, I want to thank Solomon for his time. Thank him again for his flexibility, for helping us, get this scheduled and rescheduled.
Thanks for having me.
And hopefully we'll get a chance to see you. It may not be until the next KubeCon, in North America, but until then, folks, all the things that Solomon mentioned as far as links to the quick things into the Discord and others, we'll put those in the show notes so you can easily find them. And with that, I'm going to wrap it up. I want to thank Solomon for his time. Folks, thank you for listening. Thanks for telling a friend. Thanks for helping us grow the Cloudcast community and for being with us for the last 10 plus years covering the Docker community as well. So with that, we'll wrap it up. We'll talk to you next week.